So yeah, if we don't have any questions, there is the PKI topic that I wanted to cover, but feedback on PKI first. Do you guys know how to create certificates? What is a certificate? How to procure a certificate? Why do we need certificates? Anything? Interested to know? Okay, fine. So we discussed PKI, CIA, confidentiality, integrity, and authenticity. Now, the PKI infrastructure uses these components in a slightly different manner than we saw in the site-to-site VPNs. Now, the PKI refers to any secure communication that happens over the unsecure media of internet. This can happen using IPsec, using SSL, mostly using SSL and TLS, because you are in most cases trying to establish a connection to a server. Okay, you're trying to access a service beyond a server, right? You're going to google.com, you're going to the google.com server, trying to access a web page that is hosted on google.com. But when you do that, what exactly is happening in the background? That is taken care by PKI, the security aspect of it, whenever you do HTTPS to any of the sites. So, the most established form of verification or identity verification is the certificate authority that we have. Any idea, or after reading this, like, is it mapping to anything you have seen on your PCs before? Non-certified website. When it's an HTTP traffic, right? And you're on Chrome or any other browser and it says that you should connect with a secure, this site is not secure or anything, right? How is it detecting that? Any idea? So in the background, there is some exchange happening, right? Like for example, if you go to your PC, open Wireshark, go to some HTTP site, you'll see an exchange happening. TCP, handshake, and then HTTP traffic. But if you go to an HTTPS website and you take the same packet capture, you'll see a different behavior. Now the PKI is the entity responsible for when you are establishing a secure connection, then what is happening in that background, what exchange is happening, what certificates are getting exchanged, that is all taken care by PKI. Okay, so the public key exchange or public key infrastructure, that is what takes care of all the certificate exchanges that happen. Okay, the asymmetric key exchange that we see, right? That is done by PKI. Now, imagine, so we read about DH groups, right? For example, there is asymmetric key exchange that happens mainly in the unsecure media, your PC to some service, PC to some server. So for example, we'll come back to Alice and Bob. These are my Alice and Bob, okay. So remember I asked you the difference between encryption and verification? Did anyone figure out? Because we didn't, I don't think we answered the question, right? So what do you think? We read all IPsec, there was some verification, something happening, right? There is a fine difference between encrypting the traffic versus verifying traffic, which uses the basic principle of CIA. Encryption what? Encryption what? Speak up, speak up. Okay. No, don't confuse yourself. Encryption is what confidentiality uses. It has nothing to do with integrity and this. Okay, so whenever we talk about encrypting, using encryption algorithms, it is confidentiality part. Don't get too like complicated with that. My point is, if Alice and Bob are talking to each other, when would you use the CIA for encrypting something, and when would you use CIA for verifying? Like, what are the keys you would use for encryption and verification? Like, public-private key pairs. You have read that? Those are clear, right? Yes. Hmm. Yes. So, this is where we get into PKI instead of a symmetric, because PKI is all about asymmetric key exchange, okay? Even when you're using encryption, there is asymmetric exchange happening. This is a key difference between a normal communication and a PKI based communication. The main difference between encryption and verification is how you use your public-private key pair. Do you know the difference between when you use public key, when you use private key? What's the difference? Somebody. So the difference is, whenever you want to have the peer device or peer entity, anything, you want them to understand your content, meaning your intent is sending data traffic or something. You encrypt with a key that they can decrypt with. But they have two keys. They don't have one key. So which key will you use to encrypt data traffic? Their public key. So that when you encrypt the traffic with their public key, it goes to them. They are the only people who can decrypt it. This is called encryption, encrypting in that terms. Okay. But verification, if you want to verify someone, you encrypt the traffic. So if I want to verify myself, I'll encrypt with my private key. So they will be able to decrypt it with which key? Whose public key? My public key, not their public key. Subtle difference. Okay? When they want to use my public key to decrypt something, they can only verify me. They cannot make exchanges. They cannot send me data. Very, very important difference and points in the asymmetric key exchange is when we use which key. Because the idea is all parties involved in PKI exchange have two sets of keys, private and public. Whichever you encrypt with, you can decrypt with the other key. So if you want to send some traffic and you want them to decrypt it, you encrypt it with using their public key. If you want to send your identity and want them to verify you, you send the message encrypting with your private key so that they can decrypt with using your public key. Confusing? So just to show you, for example, this is the the public keys that we are getting exchanged, okay? So this is, say, an identity card. You encrypt with your private key. Send this. You add the public key. What happened? Okay. You are able to verify because they were able to exchange their public keys in advance. So they already have your public keys. In which form? They have your public keys in the form of certificates. Okay? That is where the certificate authority comes into picture. Only if you have an established certificate authority and certificates on both sides, that is when you even can exchange your public key. Otherwise, you just cannot just meet and say, you know what, let me send you my private key and let's encrypt the data or let's verify me. It cannot happen like that. Okay. That is why whenever you go to a new website, right, and let's say in your MMC, everyone knows Windows MMC? No? Go to your MMC, go to your Windows systems and type MMC in the taskbar, or go to File and see Add and Remove Snap-in. Search certificates there. It should be there should be a certificate option there. You see that? Do you see a lot of folders? Just choose the local or user machine, either of them. Everyone is able to see that? Certificates. There is trusted CA, trusted root, personal certificates. If you go to that personal folder, if you have a machine that is managed by an organization, you might see certificates there issued by the organization itself. And if you go to trusted CAs, you'll see a lot of established CAs that actually run the PKI infrastructure. Everyone able to see? Were you aware of this before? Now, if you go to a new website and the website has a certificate that is not issued by any known CA, the certificate authority, basically a known, so I created my own certificate company and I'm saying I will issue certificates to all of you or any known devices, and you try to go to the website which has my certificate. Then what happens is, whenever you create a new connection, the certificate gets downloaded to this MMC. So in the trusted CA store, all these certificates are downloaded. Some are pre-installed on Windows, but most of these are installed or downloaded when you have first gone to those websites. Okay. And if there is a communication happening with a new website where these certificates are not present, an exchange happens and these certificates get downloaded in the trusted store. So, to establish PKI, encryption or encrypting, verification, important, and certificates. How we use these? Public-private key pair are using certificates. Okay? So just to continue this, if you had an identity, you use the public key. If you have a document or a data you want to send, you use their public key so that they can get the document and they can decrypt using their private key. Okay, this is a big confusion, so make sure you understand this. Okay. Now, very easy method to understand a certificate is, it's an identity card. It's an identity card for your router, for your firewall, if you are trying to establish site-to-site connections using certificates. Remember, we said pre-shared key and PKI. Two methods are available for identification for site-to-site, right? Second method is PKI. And SSL, basically the client-server connections that you all do, definitely uses this certificate by default. Okay. So, if you are a router or a firewall or any network device and you get a certificate, mostly what if you go to you take driving classes and then you create your driver's license, right? So there is a stamp on it by RTO and there is your information. There is a serial number, by till when it is valid, the issuer identity, very important. Who issued you the identity card? I can perform a Photoshop and print out and say that this is my ID card. The police will give you danda, right? It has to be signed by a legitimate issuer. So the issuer's identity should also be in the certificate. Okay, so that someone can verify the public key of that issuer. Because verification, public key. Okay. What else? Identity, subject identity. Your date of birth, name. In terms of network devices, it can be fully qualified domain name, host name. We avoid IP addresses in certificates because we don't want to map a static IP to websites. So we don't use that. But there are names, SNIs, there is SAN names, etc. They're all type of names or identifications for particular websites or particular network devices. So we have the subject identity. We have the public key one, where there is a stamp, your identity, So this is something that you can share with everyone. So if when you show the identity, they'll see the photo, matching or not. That is something, right? They're trying to verify you. It can be your signature as well. Banks ask your signature, they verify the signatures. And this is the issuer signature. Because issuer's name is not enough, right? Issuer identity I can print out and I can say this my, yes, I have a legitimate. But how will the officer see and look at that, okay, this is original banknotes, how we see, right? There is some RBI ka stamp is there and or other any type of identity where we see the hologram, where we see the stamps, etc. So that is the issuer identity, issuer signature. Any questions on? Able to relate? Right? So this is in terms of if you are a network device or you want to be a secure entity on the internet. So you need an identity card, that is your certificate. That certificate is issued by a genuine issuer. It has their signature, it has your signature, verification, validity, subject name, all those details, right? But how do you get that certificate? I am a new router in the market and I want to get this certificate. I want to establish PKI connections. So PKI hierarchy is something that takes care of how the certificates are issued to one entity. So this starts with a root certificate authority. Okay. Certificate authority, CA, issuer, similar, not same, similar, okay? But certificate authority is the framework that we use to get certificates, issue certificates. If I am a CA, I'll issue the certificates. If I am an identity device, I'll get the certificate. So, any idea, like have you seen this anywhere? No. So, imagine, we'll go back to the driver license example. You have the RTO office ka stamp, okay. Now, if you are in say Karnataka and let's assume that you get local identities as well, there is a chain of identification. So, if I am a driver in Karnataka, I will have a stamp issued by Karnataka government. But who is issuing Karnataka government its identity? There has to be someone above. Understood? Say the whoever is issuing the main RTO office or anything, some chain has to be there. So I request a certificate as a client. Someone issued me the certificate, someone issued them the certificate. Who is issuing them this certificate? Who is issuing the root the certificate? Like someone has to, right, verify. How will you know it's a legitimate root certificate? Like Delhi gave me the certificate. Delhi gave the certificate to Karnataka. Any clue? Anything? Like what do you see anything above? Or does it go on and on? America issued certificate to India, India issued certificate to Karnataka, like that. This has nothing to do with browser certificates in general. Any certificates. So browser certificates are certificates mostly at this level. Okay, you see hydrant CA1, hydrant CA2, sub CA2, sub CA1, you'll see all those certificates. I'm asking, forget browsers, forget certificates, but who is issuing certificate to this guy? So do you think the users will go to one root authority and say use my certificate? Then why is he a user? Why is he not a root CA? Based on trust. Trust is definitely the whole crux of this. You trust the root. No one issues the certificate to root. It is called a self-signed certificate that happens at the root level. You don't see anything above that, right? So basically, I create a company and I say I will be issuing all the sub-CA and all the identity certificates. So I am the root. I go to all the PKI authorities and whoever is managing the internet services, and I say I want to be an established root CA. I can issue certificates to everyone else. Here is my certificate. That certificate will be a self-signed. I am only signing it. No one else is signing that certificate. And this is a trust model because it has to stop somewhere, the trust model, right? Click on any folder, any other folder, trusted CA folder or any folder, and see if you see any certificate anywhere, except root. Open that certificate, go to the certificate path, a tab will be there. There will be a general tab, there will be view details, there will be a certificate path. You might have chosen a wrong local account as well, in case you are not seeing certificates, because generally in personal folder, there should be at least one certificate if you are using laptops from. Okay, look at this certificate on the screen. Ignore the cross for now, but this is a certificate issued to something called Spectrum Communications. Okay, this is the identity certificate. This is called the identity because the chain ends there. So you see a chain, right? There is a root, then there is an intermediate. So this is called an intermediate certificate, and then there is the issued identity certificate. So if we go to this and we look at the details, we'll see all the serial numbers, what is the encryption algorithm, what is the hashing algorithm that was used to create the certificates. See all the details. Someone was asking, how do we verify the certificates of from which location, right? So you have country location, you have organization, you have state location. All the details are in the certificate. If you are an established, it doesn't stop you from creating a certificate within a lab. Obviously, you can create a certificate within your Windows system for your own usage. And you have someone who can trust that certificate, you can create a communication. Nothing stops you. But when you go outside internet, do not use that. Okay, use a trusted, established PKI. Okay, so use certificates issued by a genuine vendor certificate authority, trusted certificate authority. So we go to the trusted certificate authority. So there is trusted root certificates, right? These are all the certificates that are downloaded. So when I had gone to some website which had a certificate issued by these root devices, these root CAs, my system downloaded them. Why? Because next time I go and create an HTTPS connection, I can use the existing certificates to do verification and the communication will be faster. Okay, I don't have to go to and download certificate each time and do that. So this is like cache. Okay, a certificate cache. So if I check here, let's see. See, all these certificates. Do you see any chain here? No. If you go to general, who issued, what is issued to and issued by? Same. Why? Because these are root certificates. Okay? All root certificates are self-signed. Any questions? Want me to explain anything from the screen? Where is that in the personal? That is a certificate that you get created, like you created whenever you up the system. So you run local services on your PC sometimes, right? For example, you want to host web pages or anything locally on your PC and you want to run HTTPS for that without internet or anything, it gets created for that. It should be on your PCs as well. In the root, are you in the trusted root certificate authority certificates? Okay, you might have not enabled any services to use them. Maybe. So whenever you create an AD or you want tunneling services from your PC, for example, you are hosting some bots or anything, right? You would need certificates for that. Or if you're running API services on your machine and someone wants to verify your machine at that particular IP. So you might use that in case you don't have a personal certificate. So what did we learn? The direct trust is always from the root, okay, because there is no other way to trust it or no one above who is issuing certificates to the root CA. But the controllers and routers, mostly network devices where we install certificates to create trust, what they can do is, remember initiator and responder from IPsec .4.2, right? Now, if they want to use certificates instead of PSK, what should we do? What should be the process? Should the certificates be issued to these two devices? Should there be a common CA? Should there be an individual CA to both of these devices? As long as the trust is established, you can even create site-to-site VPNs using self-signed certificates if you are a root certificate. But you have to make sure that the other device is able to get the public key from the certificate. So you install the root CA on each other. If that's not the case, and that's not the case in most scenarios, you have a common CA. You get certificates from that common CA for both the devices. So device 1 connects, I think we'll have that. So we know the self-signed certificates, right? So the first point is connecting with the CA. You authenticate yourself to a certificate authority and say, I want to request a certificate. That certificate request is called certificate signing request, CSR, okay? So first you need to establish which CA are you going to get the certificates from. Before making that PSK decision, PSK versus PKI, if you are using PKI, first say, do we have a CA in common? If you have a CA in common, authenticate yourself with that CA. meaning get the CA certificate in your system. That is when you will be able to verify each other, right? You will have the public key of the, remember in identity, your signature is as important as your issuer's signature. So you need to have the issuer's signature also in your identity card, correct? So you need a certificate authority that can sign or that can give you their certificate, or you can get their certificate. Anyway, there are multiple ways. You can get it manually. You can use something called simple certificate enrollment process, SCEP. It works on port 80. You can connect to the CA server. You can download the certificate as well. Okay, first step, connecting with the CA. You establish which CA you want to work with. Second is the authentication phase. So you want to get the CA certificate, right? So what happens? The CA, whoever is issuing the certificate to the router, they have that signed certificate, they give it to the router, and then they verify certificate signature, saying that, okay, the issuer is legit, I see the value, whatever normal identity checks that happen. For example, checking the signature, checking the validity, checking the name, checking the public key. Okay, whatever is there happens. So there is a fingerprint that, just like a fingerprint that you will have, so that you can verify, okay, this is the thumbprint of someone, we have it in our system. Just to establish that, you have a fingerprint created from the CA certificate. So you validate certificate fingerprint saying that, okay, this is a legitimate CA and I want to get their certificate. At this point, this is not our certificate we are installing. Remember, we are trying to get the CA certificate. That is the first step. Okay, not to be confused with your certificate. Because we first have to establish the common CA who will issue certificates to all the parties. Okay, clear? Okay, so you get the CA certificate, fine. Now I have CA's public key. Do I have CA's private key? No, right? I hope that's clear at this point. Okay. Now, remember RSA when you read that, when you had your PKI overview or anything. So, key generation is as important as key exchange. To exchange the keys, you need to generate the keys. So, all network devices, even your PCs of course, they can generate bits of keys which are the public-private key pair. So, we'll later do the lab, but to create the keys, you generate a public-private key pair. Whenever you create that key pair, it will be encapsulated in a file, and then you can share that file with your information so that you get a certificate from the CA. Before you send that request, I said, right, certificate signing request, you generate the key pair, because you have to install that key pair into that certificate. Otherwise, how will you get your public key? How will you even use the certificate? Because whenever you get traffic, right, you don't use a key pair that it's not any block or anything separate. Okay, you use the certificates itself. You use the certificates to use the private key, use the public key itself. Okay, the key pair is incorporated in the same system. Clear? Confusion? Okay. So you generate the public-private key pair and then you create the certificate signing request. This is like your driver's license application to RTO. You put your name, date of birth, anything, some sort of identity as well. In CSR, what are we doing? It contains the requested identity, basically your subject name, or if you have a fully qualified domain name, okay, vit.cisco.com if you want to use this. That will be your subject name. This is the name for which the certificate will be issued. by the CA. Okay. And then the key usage. Key usage is important because not all certificates are equal, even if they are at the same level. Meaning, if there is a subordinate CA or an intermediate CA, they can play a role of issuing further certificates or being an identity certificate as well. So key usage, extended key usage, these are all the details you see in certificates. Okay. So all attributes, whatever you want to create, you create an application for it. Okay. Yeah. Yeah, we'll go straight to this. So you have the subject name, okay, all the attributes. So you have that key pair, right? You use that key pair, you added that to CSR, okay, so that the public key that you are trying to share will get verified, okay. You have all the attributes. Are you a CA? See here, it's a false, meaning it cannot issue certificate to anyone else. Okay, this is an identity certificate. We already had the CA certificate in our system. We downloaded it. Now we are using the same CA to get our own certificate. Okay, by we I mean network device, endpoint, it can be anyone. Okay, and the client signature, which is created by encrypting your private key and creating a hash of it. Okay, I think that process is. Yeah. This is how you get your certificate structure. Okay, you had the issuer's identity, you had your subject identity, you serialized all your information, and then you did a one-way hash. Okay, you gave all your information. Then CA looks at it, it verifies whatever public data you have, makes a decision that this is a genuine device and I want to issue its certificate, and it encrypts using which key? It's written right over there. CA's private key. Why? Yes, verify whom? The CA. Because the signature has private key of the CA, right? Because in a certificate, remember trust. The trust is not only for the identity certificate, it's for the issuer also. So whenever the initiator responder will try to verify the certificate, it not only verifies the identity certificate, the actual validation happens for the CA certificate. Because if I trust the issuer, I trust you. Okay, that is the trust system. If I don't trust you, it's not like I don't trust the CA, because the CA is established. So the validation happens for the CA certificate also. That's why your certificates have signatures from the CA. So what's happening? Build CSR and sign it. You use your private key. So far good? We are using private key, the key pair that we generated. You send the CSR to the CA. So the CA verifies the CSR signature. How does it verify? Because when you create a CSR, there are two ways, and in most ways, you actually authenticate yourself first with that CA. Remember, first point was to connect to the CA, and then you got the CA certificate. So now you have the public key of the CA. That is why you're sending this to the same CA. Now if you send the CSR to some other CA, will they be able to generate the CSR certificate? No. That is how the CA also knows that he is asking me to generate the certificate, not someone else. Okay. CSR fingerprint is done. Okay. Again, fingerprint is nothing but the hash of all the values we are adding to the certificate. We validate the CSR fingerprint. Now, this is something that is again a trust system that you have to manually do. Okay, because if someone is just proxying a fingerprint, then definitely this process is compromised, right? So you need to have a list of all the fingerprints that you trust. That fingerprint should match with the CS certificate fingerprint. Clear? Doubts? So the CSR request is completed. Now the CA, it retrieves the certificate from the CA, which is the router in this case, verifies the signature. Again, verifying signature is verifying the public key, right? Now you as a user will get that certificate and you will install that certificate. Okay. So this was this is how a certificate actually looks like. Now whenever, this is the issued certificate. The previous one we saw similar diagram was the CSR, certificate signing request. That request has all the raw information. Once you have the certificate installed, this will have now all the ID related components, your subject name, right? You see the signature algorithm used, validity, issuer, who is the issuer, right? We still want to verify the key attributes. Can this guy issue certificate? Further? No. CA flag is false. Okay. And all certificates are based on X509 standards. Okay. Important thing. What if a certificate is compromised? Someone is trying to forge your identity and they created an identical certificate. Maybe serial number is B9 instead of B8. Will you be able to even differentiate that? So there is something called a revocation system that is in place. If you as an admin, and this is for now manual process, you as an admin realize that my router's identity certificate is compromised. Some attack happened and I want to make sure that no HTTPS traffic or no certificate based traffic should be coming to this router. Authentication should fail. What you will do is, you will create a certificate revocation, and based on that certificate revocation, whatever serial number of your certificate is, it's the CA's job, or wherever the certificate revocation database exists, you will add that serial number to that database. So next time when someone tries to connect to that endpoint or any network device, and they see that this certificate is there, they do a cross verification against CRL, certificate revocation list. If they find that in that list, they will stop the connection. Okay, CSR, CA, okay, first CA, you trust the CA, establish the CA, you generate a CSR, you get the certificate, and as a security check, you configure CRL, certificate revocation list. Okay, I won't go into the details of this, but say for example, key pair is compromised, you request revocation check for serial number 123, revoked. Now, one bad thing about CRL is the CRLs are updated. It's a database, so it gets updated. So for example, I have a compromise done today. Okay, my certificate got compromised. Until a next CRL update comes, which might be tomorrow, I will still have that compromised certificate in use. So if someone is trying to connect with me after 4 hours, they will still be able to flag this as a legitimate certificate. So there are more faster methods to revoke the certificate. We have OCSP and others. So this is how a revocation list also. Any questions? This is like it's the job of admin, or you can automate this process on the CRL system to add the certificates to the list, okay? Or you can decrease the time of the certificate update. Now I think we covered this, right? Validation. Just go through this. Whenever you see a certificate, your first glance should be the validity of the certificate. Is that certificate expired? If that's expired, let your admin know. Okay. So revocation check is something that we add in the, I'll come to trust points later, but just think of a trust point as a certificate container. Okay, you have a container, you have the certificate stored. So in trust points, we can create revocation checks. If that check is enabled, you will always, whenever you're establishing connection and you're exchanging certificates, you will look at the CRL list. And if there is a certificate serial number matching in that list, with whom you are establishing the connection, you will stop that connection. Okay? So once the certificate, you have the certificates and all established, so you will get the public key, you'll exchange the certificates as usual. They get the signed nons. The certificate proves that key pair is really Bob's. And then the private key also, whoever is decrypting the packets, they'll be able to read depending on the identity. What if all this is good, okay, but what if there is a man in the middle attack who has this information? They don't need to have the actual decrypted information or non, or the actual data which created the nons. They can forward it, right? You don't need private key to do that, or you don't need to decrypt it. So we get that information, and the attacker who's in middle is just forwarding that information. Can happen, right? How do you think we can mitigate this? You can actually not. So the thing is, you, as much as you want to attack these key exchanges or the certificates, right, it will only be to the extent of the information that is getting exchanged over WAN. Meaning, once you start passing the traffic, you will need the private key to decrypt. So these attacks happen, very not that common because we have other mechanisms, but in case you get an attacker in between and you have a certificate information, all you can do is forward it to somewhere else. But once there is data traffic that travels, remember main mode, quick mode, and then the data traffic. Once the data traffic starts, you will not be able to decrypt that traffic, because That is why this asymmetric key exchange is important. Even if the public key is compromised, even if the nonce is on WAN and it is visible to everyone, unless and until private key is compromised, it is of no use. You can proxy yourself as a CA, you can proxy yourself as a legitimate issuer, but at the end when the key match happens, right, the three keys establishment, or even in SSL we create a pre-master, using pre-master key we get session keys. Whenever it comes to the usage of those session keys, we need the private key or we need the private information to decrypt it. Okay, this is a use case, but yes. So just an overview again, I won't go into the details. We had with the pre-shared key, instead we actually mentioned, remember in the first packet in PCAP we had authentication method pre-shared key. Instead of that there will be RSA, and whenever there is that identity payload, whenever that we are sending at MM5 and MM6, we'll send the certificate information instead of pre-shared key or anything. So the key exchange that happens, in the DH key exchange that happens based on certificates that we have. So both of these, initiator and responder, they need a common authority or at least someone they trust. They have the certificates pre-installed, their certificates and the common certificate. It's a chain, remember? You need the chain, CA and the ID, or issuer and the ID. And then you exchange as usual. Just in the, if you see at the third and fourth packet, there is a certificate request, additional certificate request packet that's added. Okay, that certificate request, what the responder will do is, the responder will send their certificate, initiator sends their certificate, and the identity establishment happens there. Okay, any questions? Actually, I will not. So in box folder, okay, do you have the PCAPs in box folder? Can you open? No, not day 2. Where you got the IKV1.pcap from? Let me open here. I don't know if this IKV2 has the certificate exchange. One key difference in IKV1 and IKV2 is that in IKV2, even the identity and nonce part, so basically proposals and the nonce part all go into the same packet. So we had 6 messages, now they become 4 messages. Okay, and the quick mode, there's no main or quick mode in IKV2. Whenever you see, do you see in the screen create child SA packets and ESP packets, right? Whenever we see this IK auth packet, this is where the identification is also done, where all the quick mode negotiations are also done. They're done in the same packet. And once that establishment happens, we create something called child SAs, where these are the proxy IDs. Remember the proxy IDs where we are establishing? Similar to that, we call it traffic selectors in IKV2. Okay, won't go into much detail. I wanted to show you. Go to day 2 labs and there is an OpenSSL lab. Anyone familiar with OpenSSL? Used it before? No? Okay, interesting. That is a very nice tool whenever you want to create certificates, key pairs for any of your labs, in case you have any academic labs or you are interested in knowing how certificate structures looks like. So we'll go, just open that lab. Do you have anyone using Jupyter or Google Colab? Like you have it on this system? So you can open the IPython file directly. Otherwise, open it as a notepad file, whoever doesn't have Jupyter or this, and just go through that go through those commands now. Should I open it? Then I'll open it. So I had done this lab, so I have the outputs already printed, but you do it by from scratch, okay? Now if you have Kali Linux also, you can run these commands. On Mac, OpenSSL is installed by default on Mac and Linux. If it's not in Linux, just do apt install or sudo get OpenSSL, you'll get it, okay? Let me know if you are able to open the IPYNB file apart from Jupyter. Like, are you able to open it in Notepad or, okay. And you have a Python environment to run this, or if you have any other environment, OpenSSL commands, you will get it on internet, or I think they'll be the same. If you have Linux box, you can run them directly. First install OpenSSL. Okay, make sure. I think if you do OpenSSL -, version, you'll get it, if it's installed or not. So OpenSSL is something that generally people use to convert the types of certificates. I didn't go into the types of certificates, but certificate formats can be different. One is PEM, another is PKCS 12. These are different types of certificates where the keys either are present. So in PEM, you don't have the key file. You only have a base64 file that's incorporated into the .pem file, or .cer file. .certificate file is another type of file. They all contain the same information, it's just different formats. In PKCS 12, it's special. It has the keys, the identity and the CA, all of the information in one file. So you can just, you encode it encrypted using a passcode. Whenever you want to install it on a device, you select the PKCS 12 and you enter the passcode again and it will install it. So mostly personal certificates that you install on your PCs are all PKCS 12 files. Whenever you get it from somewhere, or for example, you don't want to go through the CSR process, go to CA, get the certificate back, you can just create a PKCS 12, and for example, your device has gone faulty, you get a new device, you just install a PKCS 12. Your certificates are restored. Okay, there are good ways to restore the certificates or store the certificates. So the first step here is, just let me know once you all are able to at least open these. So you have to run the first command to connect to a runtime. So a dedicated CPU or GPU is given to you for that session, and then you can run those commands one by one. Or if you want to experiment, just try different bit size, different names of the keys. What I have given you is an example, okay. So we start with the key generation, remember? Now, sorry, before that, yes, we have to first create the root CA. We are creating here a root CA, sub CA and an identity chain. Okay, at the end of this lab, you will get a certificate that has an issuer and that issuer has a root certificate. So, you have to go through step by step to get that certificate with the chain. So, first to create the root certificate, we need the RSA key pair for root. So, you are the root certificate creator, so you do that. After that, you create the root certificate and then you create CSRs for your intermediate, get it signed by root. Now, using this process, this is fine. In industry settings, for example, on Cisco routers, we don't use OpenSSL. There is a separate method on routers. I'll give you a lab for that. So just, I mean, we learned IPsec in detail, right? Whatever is happening between an initiator and responder, in SSL, it now becomes a client and a server. That's the first difference, okay? In IPsec, we had IKE, the outer protocol, and then ESP, the inner protocol, the framework, the key exchange, etc., right? In SSL, what happens is, the first step is you have a TCP handshake happening. SSL port is SSL TLS port. Do you think there is a difference between SSL and TLS? What's the difference? No. So, anyone? So, SSL was the first protocol, the RFC that was written back in 1995. Okay, then it got renamed, a new version with more enhancements, 96 V3, and then it became an IETF standard, which now is called Transport Layer Security. So, even when you see SSL in the packet captures or anywhere, it is TLS. Okay, TLS is the new name of SSL. Okay, that has become standard. Now very recently we got TLS 1.3 itself. Before that there was TLS 1.0, 1.1, 1.2 as well. Okay, so what it does is, it sits where? It's a two-layer protocol. One is a record layer where you're actually exchanging the data. Remember IPsec, ESP, it's similar to this. And then handshake layer, where you talk to the end devices, basically the exchange that happens between client and the server. Okay. Again, you have public-private key pairs. What happens is, client sends TCP SYN ACK, TCP port 443 is SSL TLS, okay? 443 default. Now, once only the TCP establishment happens, the client sends something called a client hello packet, very similar to MM1. So, client hello will say, I support these ciphers, I support this key exchange algorithms, okay, this RSA group, and what are all the other attributes that we want to establish with this connection. It can be the RSA signature, etc., with certificates, versions that we might handle or we might support. All these information goes into server hello. Client hello, sorry. Server hello is where, because till now server doesn't know that the client exists or not. It's like whenever you're visiting a website, you establish the connection. The server understands that the client wants to establish an SSL connection. Server accepts those proposals. Again, whichever is a matching proposal, it will accept it. Okay? Then it sends its public certificate. This is where it's different than IPsec. Okay? Server sends its public certificate. That certificate is used to establish the session keys later. It sends also the nonce, also public key information, any request that it might do, and it also can ask for client's certificate. Certificate request, it's an additional field that goes. For example, you don't want to use username and password for that Again, this is all remote access VPN. Okay, just to recall, we had site-to-site VPNs, IPsec is the main protocol. Remote access VPN, you're trying to establish from your PC, trying to access a resource that is in some server side area, right? Some application, VIT's lab you're trying to access from your home. Those kind of remote access. There is no LAN to LAN. It's an on-demand connection that you are establishing. Okay? So this is where SSL, so you get the server hello message. The server hello contains the certificate of the server. Additionally, if the server wants to authenticate the user based on certificates, it will send a client certificate authentication request. Okay? If this is not done, then a PEEP or a EAP request goes, which is the username password packets that are there. Okay. Okay, imagine the client side has 10 certificates issued by different CAs. We now know, we have established CA, certificate authority. The server will send the certificate request for what? Will the server send the certificate request for the CA? Will it send for the client identity? Or will it just send a certificate request saying send me any legit certificate you have? Like, what do you think logically? Speak up, speak up. We'll go to lunch, don't worry. Anyone? So it requests all these certificate types. Reason being, if you are in a network device, if you are a network device and you are establishing, or say for example, you're a PC, there's a router here and you are trying to establish a remote access SSL connection. Whatever CA issued you the certificate should be present on the server side. Why? Whoever issued you the certificate as a user should be present on the server side. Make sense? Why? We want to establish the trust with it. Okay? We trust that CA server, so whoever issued the certificate to that user should be present on the server. If there are 10 such CA servers, for 10 such users, the CA will send the certificate request with the list of all the CA servers it has, or rather it supports. Now, if the client has a certificate issued by any of those CAs, then only it can send the certificate back and the session will continue. Because we cannot establish trust outside SSL, before SSL, right? In IPsec, we were giving the identity message in MM5, and then we were cross-verifying if that identity matches, and we were creating 3 keys. Not happening here in a similar, like in the same way. That is why it is, if you are doing the certificate exchange or certificate authentication from client side, you send all the CAs that you already have, a list. The client looks at the list, first match, okay, I have a certificate from this CA, I'll send my certificate for that CA. Server receives that, server says, I'm okay with the certificate, let's do the key exchange. Same key exchange, similar way, the whatever certificate information you have, nonce, public key information, all is encrypted, hashed, created, you send that information in key exchange. Key exchange is same, very good. And then there comes a change cipher spec message. This is the last message that happens before encrypted data starts. This means for this particular session, before this session I was using some set of ciphers for the data plane. Remember, this is again till your control plane, right? Now for the data plane, I was using a different set of ciphers. I want to change those ciphers to use these new ciphers that I establish, and I'll use the session keys that I got from this session. Then symmetric key is generated on both sides, similar to the keys we generated. IPsec, same keys on both sides. That is how we know we can encrypt and decrypt the same traffic. We had then the ESP inbound, outbound, right? Similar to that, we get session keys. These session keys are symmetric keys that we establish, and when we have data transfer, it is faster. We just use the same key to encrypt and decrypt. And the outer layer is the SSL that we got. Overview, not going into much detail of it, but yes, this is the. Any questions? So yeah, just look at this in case. Now remember, similar to how till the identity payload is sent and we don't know if the other device can even encrypt or decrypt the traffic, here also when we send the chain cipher spec, we don't know if the server can encrypt or decrypt the traffic yet, because we don't know if the keys that are generated are same or not. It's just the trust process that because we started with the same certificates, same trust value, we use the same proposals, same exchanges. When we send the chain cipher spec, the first data transmission that happens from the other side will be able, you will be able to decrypt it using those keys. So it can fail if this doesn't match, it can fail after this. Okay? And so this is for a new session. If you are resuming a session, now again, you cannot resume IPsec sessions normally, another difference, okay? If the IPsec session, I mean, there is a timeout value, because why? That is always on. This is on demand, right? The LAN traffic is kind of always on connections. So you always start from the first packet, first exchanges. Here, if you have opened the browser for a while and then you're coming back or closing and you want to resume that session, right? And you reopen the same, you've seen it loads faster than the first time. So it's resuming that TLS session, and when you send the first client hello again, still the SSL handshake happens, but there is a cookie value for the resume session. Okay. So yeah, we were saying something about moving towards passwordless username and password, right? The security assertion markup language, or SAML. Remember yesterday when I was showing my website and there was SSO, single sign-on login. This is the operation of that SSO. So whenever you, for example, you're a student here and you're trying to access a web page or a resource from VIT Vellore, the VIT Vellore's system or admin, they can choose to give you access to one resource only if they want. Even though you connect to all the resources through VPN or through any site, they can restrict that access to one resource. There are a lot of ways to do that, but SAML is one way where we add the authentication level, we can do that. So if you have, you can use it in two ways. One is single sign-on, you just sign on once and you are able to access all the resources. Okay, so in this case, service provider is your, so there are two terms, service provider and identity provider. Okay, who do you think is the service provider? For example, you have an AD where your username passwords are still there. Okay, we have not moved away from them. But on the VIT Vellore campus or the admin side, you have a lot of resources, and you can do authentication using SAML. So what do you think is the service provider? What do you think is the identity provider? AD versus your VIT admin. AD is the identity provider, because identity provider is the one who is providing you the authentication checks or marks that you are doing. Okay, as a user, when you come to the VIT Velour homepage and you want to sign in, the request first goes from the users to the service provider, which is your VIT Velour. Okay, Meraki is a Cisco product that is just used for the example, but user connects to the service provider on an application. By application we mean web application, any application that you have. The authentication request is sent from the service provider to the identity. It gets forwarded to that identity provider. Okay, identity provider can be your Azure AD, AWS AD, or Microsoft AD, or any Active Directory you might have. And then it is the job of the identity provider to contact the user directly. So your VIT Velour is not part of the authentication process anymore. You're not giving the load of identity verification or anything on the VIT Velour admin anymore. Okay, so there is a pop-up that opens on your screen if you use SAML, and that web browser that connects to IDP. IDP verifies whether you're part of the database or not, and what application access you should get, and directly it gives you a SAML token, and once you get the SAML token, you can use that token to go back to your service provider and say, here's my token, I'm a legitimate user, give me access to these resources. Now your SP's job is to restrict the usage of your SAML access. They can give you access to just one resource, 10 resources, or they can say sign in once, access everything. Or they can have per application sign-ons as well. So that's how, this is the most recent authentication. I mean, there's passwordless as well, there's TLS 1.3 certificates, etc. But this is a common how we are doing SSOs in organizations and stuff.